All right, we are cruising. So as you can see, we're up to 511 day 2. Now the title is Applications of Exponential Functions, but I think that title has more to do with exponential growth, decay, and you're going to see what I mean as we kind of go through this lesson. But let's dive in. So the problem asks us, use the graph of y, or g of x equals negative x squared plus 4. We can see it's a parabola. Parent function y equals x squared, to sketch the graph of y equals 1 over g of x. So, reciprocal function. So let's start with this. Now I do want to show you something. If I took that negative off, this would raise it up 4, and then it would be up like this. But because that's a negative, it flips it. And we've kind of talked about that a lot, so there you go. Now there is a PEMDAS challenge here, and a lot of students screw this up because really, a lot of students would square that negative when they're plugging things in, and that doesn't happen. For example, negative 3, I'd square that, it's 9. But that's negative 9 plus 4, which is negative 5. If I put negative 2 in, negative 2 squared is 4. Negative 4 plus 4 is 0, on and on and on. Now these 2 points here, I'm going to show you something else about it. They're called my zeros. I could have recognized that this is a difference of 2 squares, flip them, factor it, 2 minus x, 2 plus x, and my zeros would be 2 or negative 2 by just looking at these. So different way of doing it. This way we would just stumble on it. This way we would actually purposely find it. And these zeros are very, very significant because you see this g of x, wherever g of x is 0, it can't be possible. So from this, I know, let's go over here, I know that if I plug negative 2 in, I'm going to get, and I'm talking about this, we can't have a 0 in the denominator, so x cannot equal negative 2 because g of x would be 0, and I can't have a 0 down there. So I know right away my asymptotes, x cannot equal 2 or negative 2, so that's how I get started. So there's x equals 2, and there's x equals negative 2. That should be straight. So x equals negative 2. Now I want you to look. We have 3 different sections. And the intention of this is to do it without a calculator. So we got to use our head. Well, I'm going to pick this is section number 1. I'm going to call this section number 1. Section number 2. Section number 2. Section number 3 is right here. And as you can see, what I've done, I've picked a number way over here, 2, 3, 4, 5, 6, 7. I want to see what happens over here. It's easy to plug in negative 10. So, if I plug negative 10 in here, negative 10 squared is 100. That's a negative 100. Plus 4 is negative 96. So it's 1 over negative 96. So I get negative small. So I know way over here is going to be it's going to be barely, so negative 10 is going to be barely underneath the x-axis. Then if I plug in negative 2.1 here, negative 2.1 is 4.41, but negative 4.41 plus 4 is just 0.41. So it's negative, pause. Malfunctioning brain. All right, sorry about that. So, I go back to here, negative 4.41 by plugging in negative 2.1. Why did I plug that in? Because it's just on the other side of x equals negative 2. I want to see what happens really close to the asymptote, and it's going to give me a picture of what's going on. So, here's what I forgot to do. Plug that in. I get negative 4.41 plus 4 is negative 0.41. So I need to put that right in here. So if I get negative 0.41, that's really negative 41/100ths So then I would flip it, and I would get negative large. So if I go barely over here, it's going to go way down here, and I can see it's going to go something like this-ish. So we're just getting a sketch. So now we go to this one, negative 1.9. So now we're investigating what happens here, so I want to get close to negative 2, find out what happens over here. So if I plugged in negative 1.9 right here, negative 1.9 squared is 3.61. Now that's negative 3.61 plus 4, so that would be a positive 0.39. And I put that right here, so it's really 39/100ths. Flip it, I get a pretty good number, large. So it's positive, big, negative 1.9 up here somewhere. And then if I plug in 0, I can see that'd be 0 plus 4. And then I go 1/4, that's 0.25. So I go 0.25 would be right about here. And I can see that if I put 1.9 in and square it, it'd be the same thing as putting in negative 1.9 and squaring it, so I can steal. These two things are going to be the same. So then they go up, and I can see, it'll look something like that in region 2. Then I go to region 3, and the same thing. These things are going to reflect each other, because 2.1 squared is the same thing as negative 2.1 squared. Why did I pick 2.1? Just on the other side of this asymptote. So it's like just out here, and then I get negative large, so that's way down here. And then I plug in 10, it's way over here, and I get something very negative small. So that's going to come in like this, and like this. And after you've done 10,000 of these, you'll notice 3 sections, you're going to have this kind of reflect this, and then in the middle it does the opposite of what these are doing. So there you go. We graphed it by hand. A lot of work there. And I almost screwed it up. All right, next problem. We're going to talk about a weird twist on a piecewise function, and they're just going to have you manipulate it to find the truth. So here we go. Given the piecewise function, boom, x is less than or equal to 2, x is greater than 2. Notice this is kind of the connection between these two graphs. So let's really remember this. What must the value of a be so that y equals g of x, that's just this, that means all of this, is continuous, again, there it is, at x equals 2. That's a huge hint saying plug in x equals 2 to both of these. So I get y equals, talking about this one, 2 squared is 4 plus a. Then I plug in x is 2 for this one, so then I get y equals, let's see, 2a minus 6. Y equals this stuff, y equals this stuff. So I'm going to set this stuff equal to each other, so 2a minus 6 equals 4 plus a. Now if I subtract a from both sides and add 6, I'm just going to get a equals 10. What do I do with that? Well, now I know this is a 10, and I know this is a 10. Now how do I show that it's continuous? Well, if I graphed y equals x squared plus 10, it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's the vertex because of that. So it's y equals x squared shifted up 10. So I'm going to get it. Oh, and by the way, I almost forgot. The pivot point where they're connecting is x equals 2. So I'm going to put that in here. 2, and if I put 2 squared is 4, 4 plus 10 is 14. That's a very significant point. So 2, there's 10, 11, 12, 13, 14. So on this side, my parabola stops. Notice it's less than or equal to, that's why I filled it in. And then this would go like this. Now we've got some work to do with this other one. I'll just use green. So if I say x is greater than 2, but I know this is like the turning point, I'm going to plug a 2 in there. So 10 times 2 minus 6 is 20 minus 6. So the corresponding point is 2. 14. So notice 2, 14. Now it's filled in for this one, open for that one, so technically it's filled in. It wants it to be continuous. And this would simply be this graph. So minus 6, 1, 2, 3, 4, 5, 6. There's the y-intercept. And then we know that it goes through that point. So we're going to go like this, and like this, and like this. But notice x is greater than 2. It only wants this portion, none of that. But I graphed the whole thing to kind of get an idea of where it's going. And now it's continuous, so we did our job.